Section 4.5, Properties of Logs. In this section, we'll use the product, quotient, and power rules of logs. We'll expand and condense log expressions, and we'll use the change of base formula for logs. There are three rules of logs that are analogous to the three exponent rules: the product rule, the quotient rule, and the power rule. So I just want to show you how they're analogous to the exponent rules, so that way if you're ever wondering or can't remember one, you'll just know, oh, I know how to use exponents. Since I know how to do exponents, I can do logs. So product. Remember, if you have something like x squared times x to the third, the fast way of figuring out what that's equal to is you just add the powers together. So that would be equal to x to the 2 plus 3, in other words, x to the 5th. It's the same with logs. If you're taking log to the base b of a power, it's the same as adding the logs together. Let's do the quotient rule. So remember, if you're doing the quotient of exponents, for example, x to the 7th divided by x to the 2nd, the fast way of doing that is to take 7 minus 2, or in other words, 5. So when you're dividing with exponents, you subtract. Exactly the same with logs. Log to the base b of, if we're working with a quotient, it's the same as subtracting the logs. And finally, powers. If we had something like x squared raised to the 5th power, just as a reminder, the fast way of doing that is to multiply. So this would be equal to x to the 10th. Exactly the same with logs. If you're taking the log of a power, it's the same as multiplying the power by the log. Now, this probably doesn't make any sense right now, but you'll see how we use these in just a moment. So you can use these rules to expand or condense log expressions. We rarely need to expand log expressions. However, we need to condense log expressions in order to be able to solve equations involving logs. So expanding a log expression means to write it as a sum or difference of logs. So for example, use the rules of logs to expand log, and you'll use a common log. So base 10 will be our base. Log of 2x times x plus 4. Now notice this is the log of a product, and the log of a product is the same as adding the logs together. So we'll start by saying, oh, this would be the same as log of 2x plus log of x plus 4. And finishing touch, since we're looking here and we're going, oh, that's also a product, so we can break that up even further. So we can write that as log of 2 plus log of x plus log of x plus 4. And now what we've done is we've broken that expression into the sum of 3 logs, and none of which can be simplified any farther. We'll do another example. Use the rules of logs to expand log to the base 4 of 5x divided by 6. So with dividing, quotient, it's the same as subtracting the logs. So we're going to start off by going, oh, this would be the same as log of 5x minus log, and the base is 4, of 6. This is a product, so that would be the same as a sum of logs. So that would be log to the base 4 of 5 plus log to the base 4 of x minus log to the base 4 of 6. And now, none of these can be simplified any farther. You can go backwards too, using the log rules to condense expressions. So we're going to use the log rules to condense each of these. So our goal at the end is going to have one log in the expression. So here, we see that we're adding 2 logs together. That's the same as multiplying 5 times x. And here we see we're subtracting. That means the same as dividing. So when we're done, we would have log to the base 3 of 5x divided by 8. We'll try another one. Well, I was about to multiply those together, but there's something we need to do first. See how this one has a number in front? Now, back up here, when we look at the power rule has a number in front. When we have a number in front, that's the same as the power. So the first thing we're going to do on this one is to rewrite this as a power. So log to the base 2 of 5 plus log to the base 2 of x to the third, using the power rule, plus log to the base 2 of y minus, and then in parentheses we have these two. Let's go ahead and take a look at the parentheses. So in the parentheses, again, adding the logs is the same as multiplying. So I'm going to change that to log to the base 2 of 4y. Okay, now these are all being added together. Adding is the same as multiplying. So we have log to the base 2 of 5x cubed y, and subtracting is the same as dividing. So now we've condensed that into one log expression. Here's one for you to try. Now, I'll get you started. Remember, we're going to do the same thing that we did before. Whenever we see a number in front of the log, we're going to rewrite that as a power. So start by saying this is the same as log to the base 3 of 4 minus log to the base 3 of x cubed. And now I'll let you do the finishing touch by yourself. The last thing in this section is a change of base formula. So you may have wondered, well, how do I do logs on my calculator if it's another base? We know we can do common logs base 10. We know we can do natural logs base e. But what if we have another base? So the change of base formula. It's used only if you want to evaluate a log that's not base 10 on a calculator and also not base e. So log to the base b of m, so some other base. Well, we're going to approach this the same way we've done before. We want to know what this is equal to, so we'll just say, oh, it's equal to some value y. And then how do we work with these? We're going to rewrite this using exponents. That tells me that b to the y is equal to m. And what we're interested in is what would y be equal to? So what we're going to do is we're going to take the log of each side of this equation. And I'll just use a common log. You might say to yourself, well, how is this going to help me? Good question. Well, because of our properties of logs, I know I can bring down this power. And remember, what we're trying to do is we're trying to figure out what y is equal to. So because of the power rule, we can rewrite this as y times log b is equal to log m. And remember, if I want to get y by itself, we'll just divide both sides by log b. And this gives us our change of base formula. If I want to know what it's equal to, we should take the log of m and divide it by the log of b. All right, so how do we use this? Evaluate log to the base 4 of 62 on a calculator. Round your answer off to 3 decimal places. Well, according to the change of base formula, this is going to be equal to the common log of 62 divided by the common log of 4. And you just take your calculator and do that simple calculation. Log of 62 divided by log of 4 will give an answer of 2.977. Okay, here's one for you to try.